Hello everyone, it's Mr. Alvin from Access Math, and today is the final video for polynomials, and I'll be going through a question on cubic polynomials, doing long division on it, and solving a question on cubic inequality. So without further ado, part A is to solve for an unknown coefficient, and to solve this we have to make use of the factor theorem, knowing that since 2 is a zero of fx, right, we know that substituting x with 2 results in 0, so I will have f2 is equal to 0, giving me 2 cubed plus 2k minus 2 is equal to 0, and this gives me a value of k to be negative 3. Now, if you are still unsure about factor theorem, I do recommend you to revisit the video 2 weeks ago. Now, for part B, it's a question on long division now, covered in the previous video too. So, to factorize the cubic polynomial, we will execute a long division. Now, since 2 is a 0 of fx, x minus 2 must thus be a factor of fx, and we now have x cubed plus 0x squared minus 3x minus 2. Now, recall that I do like to have a 0x squared as an empty placeholder for missing powers in order to make the long division neater. Again, you should revisit my previous video to revise this if you have forgotten about this. So the divisor is x minus 2, giving me x squared (2x squared minus 3x plus 2x, 2x squared minus 4x, sorry for the spacing, x minus 2, and plus 1. And we are done. So the polynomial factorizes to be fx is equals to x minus 2, x squared plus 2x plus 1, which can be factorized into x minus 2, x plus 1 squared. Alright? Now, part C is the main point of this question itself. Firstly, I want to bring about a few teaching points. This here is what we call a double root. A double root is also a turning point of the cubic graph itself. So in terms of sketching this graph quickly, we first identify the roots, which are negative 1 and 2 itself. Noticing that negative 1 must be a turning point, and this graph actually has got positive leading coefficient. Because the coefficient of x cubed is positive, the graph can only look like this now. I'm not exactly sure where the second turning point really is, but that's not the concern in this question at all. And I can add on by, after labeling my axis, that the y-intercept must be negative 2 when x is 0. Alright? Now, to solve this inequality quickly, we just look for the range of x value when f is positive, and f is positive right over here, which corresponds to this set of x values, and hence the solution is just x to be greater than 2. Alright, this answers the cubic inequality question. Now, as a final farewell for this chapter, I just want to revise with you the shape of a cubic graph in general, and a quadratic graph too. For a quadratic graph and cubic graph, we always look at the polarity of the leading coefficient to determine its shape. For a quadratic graph with positive leading coefficient, we will always have a U-shaped curve. And conversely, for a negative leading coefficient, we will have an N-shaped curve like this. Alright? For a cubic polynomial with positive leading coefficient, we will be having two turning points and a graph like this. Whereas a cubic polynomial with a negative leading coefficient will have a shape like this. Alright? So these are theories that you should have in mind at all times in order to solve the question appropriately when the time comes. Okay, that's all for me today. Take care. Feel free to comment on our comment section if you have any topical requests. I see you on the next video. Goodbye.